Okay, so I'm going to talk about the fan survey, and this I think was the thing that we were most interested in, and also the most challenging. We actually went to companies in Hawaii, like Island Cooling, and then there's like a fan company actually called Big Ass Fans. That's the name. And they put in big fans at the airport, for example, and we asked them, like, how do you, like, they're actually a known good product. We're like, how do you measure if your fans are working for people? Like, so we got into the idea of actually measuring airflow, but that's actually not. They said really it's subjective. It's really how people feel. So we took a lot of time to try to figure out how we could measure that, and we came up with something. So we tested a bunch of different scenarios of fans during the summer school class. So it's a full classroom. It's in the hottest time of the year. And the students were actually doing a bunch of geometry problems, so we'd kind of come in between their problems, switch the configuration, let them get acclimated to it, and then ask them how they felt. And we did it with different scenarios. So here's the scenarios. Whoops, did I go backwards by accident? Let's see. Here's the scenarios. So this is just how the teacher had the room set up, and you can see that the doors are on the south side, the windows are on the left, which is the north side. And you have fans up with the H means they're on high. And that's where the teacher just happened to have it, is facing the back of the room and the corner of the room. So we started off the room before the class got there with them off. So they walked into a situation with no fans on. The windows were open though. And then scenario 2 is we moved them so that they were more diagonal to each other and taking advantage of the airflow coming in, perhaps through the door. And then we had them from another direction on medium, and then we did the same thing on high to see if there was a difference between medium and high. And then we also did, let's see, what was the difference between these ones? Doors closed and opened, right. And then 3 fans, taking advantage of the doors and the window, and then 4 fans.
Okay.
And the way that we measured it was this. We came up with this scale. So we asked them before we started to kind of put a number 1 beside wherever they felt they were at. If they were on the warm side, they put it in the red region. If they were in the cool side, they put it in the blue region. And then as we tried each scenario, we'd come back in after they'd had a few minutes of doing a problem where they forgot all about us, and then just say, put a new number on where you feel that you are and how it changed. And so we wanted to track the relative difference. So basically we said, if you started off in the farthest extreme warm dot and the fans came on, if you felt a change, say that, you went 2 dots to the right. If you felt a little bit of change, then you just go 1 dot to the right, that sort of thing. This is completely subjective. It's, the probably as least scientific, but as best as that we've ever heard of anyone doing, unfortunately. Yeah, there's an interesting thing. So here's the differences between all the different scenarios. So if you look at the scenario 1 where it says negative 0.46, that means that it went that much cooler in that direction, 0.46. And then going from scenario 1 to 2, it went a negative 0.42, so it got a little bit cooler. Going from scenario 2 to 3, there was no change. These are relative numbers, not absolute numbers, so it's just showing a slight difference. If there's a negative v in front of it, that means it got a bit cooler. If it's 0, it didn't change at all. If it's positive, it got a bit warmer. And the only way these numbers make any sense at all is just by relatively comparing them right here, as you see, right? But I'll go through each one alone. If you look at the scenario 0, which was how it was with nothing on in the room, the green section would be it feels just right, and the red section would be anything in the red gradient means it's in the warm side, right? As soon as the fans came on, you can see that it went to the green got much bigger and the blue got much bigger. So just having fans turned on made a big impact, just that alone. That's, I think, probably the biggest change that we noticed, and the strongest result is that there was a noticeable difference. If we go from scenario 2 to 3 to see what the difference was, when we changed those 2 fans to try to take advantage more of the windows and the doors rather than the back of the room and the door, not much of a difference. So it goes to show a little bit that it's just more about having them crossing each other, being opposite to each other. Going from 3 to 4, what was that one again? Going from medium to high, there's a slight difference of negative 0.38. Remember, these are tiny numbers, but relatively speaking, that's what we're going with. The biggest change was negative 0.48, so this one's actually considerable. It's almost as much of a change as going from no fans to fans, going from medium to high. Then next one, When we went from 4 to 5, which was going from the doors open to the doors closed, it actually there was a noticeable warmer. It got warmer. So having the doors open is important. And this one was going from 3 fans to 4 fans. There was zero difference, I've noticed. So having that extra fan doesn't seem to make a difference. And I think, you know what, I think there was one also that went from 2 fans to 3 fans, and there was a perceived a bit warmer, actually. So.
What would happen if you put the 2 fans near the windows on this side
and just have
blow
them
it out
pointing into the room? Yeah, we didn't do that one.
That would be interesting.
That would be interesting. We thought of as much as we could at the time, and then you think back and you start to think of more things you could have done.
Well,
but yeah,
would help improve the circulation. Yeah, you can blow it out towards the door, right? The hot.
because if it's coming in from that one side and going in the other side, it could be. Yeah, it could be. We were actually going on literature that had said that fans face across from each other the most impactful, so we started from there. But now that you say that with the trade winds going, it probably would have been a really good experiment. Yeah. And then, let's see, yeah, so going from 3 to 4 fans for sure did make a difference though, which I thought was a powerful thing. So, bottom line, each class has the capability, let's assume that each class would have 4 fans, the absolute highest scenario. And then we wanted to compare what forced fans versus AC calculations would be. And in the report, we actually did 2 fans as well as an after effect, because we're like, even though, because we always try to do the most conservative numbers. So we're saying, because some rooms do have 4 fans. So we tried to say, what if every single room had 4 fans, the absolute worst case scenario. And then in the report, we also did, what if every room had 2 fans, which seems to be the most ideal scenario since you don't gain much from 3 or 4 fans. But looking at the worst case, every single room having 4 fans, it just froze for a second. We did calculations comparing what it would be if there was it went, so it's good. Yeah. So we looked at the cost of running 4 fans per year, and then the cost of running air conditioning in that same room using an energy efficient window air conditioner, and what the savings would be. And you can see from the bottom that the total cost of fans would be under $9,000. You can cut that in half for 2 fans, so it'd be more like the $4,500, which would be the ideal. The AC cost would be about $73,000, so you're saving $64,000 a year just by using fans instead of air conditioning. Just to show what
rule of thumb looks like 1 to 8.
Let's see, yeah, that looks good, and yeah. I mean, if you think of the 2 fans per room, does that still hold?
This is 4.
In the incremental.
It would go higher,
Yeah.
because
Yeah.
this is for 4.
Yeah.
This is for 4. So, in the report, we emphasize that this is the one time we said instead of going the worst case scenario, let's go the most ideal, which would be 2 fans per room, and that it would be more like, I guess, in the 4, let's say 5,000 even, and compared to 75,000. Yeah.
What kind of fans were these?
Floor fans.
Floor fans.
Regular floor fans.
Residential.
That have,
Right.
regular
Right.
residential ones.
Correct.
We actually looked into buying ones that were vortex fans. We considered it. We actually went and looked at them, and then we're like, well, why don't we use what's already being used, and do that instead.
Were these fans sweeping or stationary?
Stationary. I think they could be sweeping, but they were stationary when we used them, and they had 3 settings: 0, medium, high,
Oh, I see.
or 1 medium, high. Yeah.
Do you think the results would have been different if they were sweeping or better? Or probably better?
Hard to say. Yeah, that's another thing we could try. Could those ones sweep?
I think so.
Sweet.
Yeah, I think they
Sweep.
could. I think they
Never thought
could.
of
Yeah.
that too.
Yeah.
I just wondered.
Yeah. I think the sweeping idea and the other ones, this is iterations for next time, right? Yeah.
Thank you.
Yeah, no, thank you.